Okay, well, welcome to our chemistry lesson today, which is on limiting and excess reactants. This is a tricky one, a lot of steps involved, but let's get right to it. Anyways, a limiting reactant versus an excess reactant. So far in all the chemistry questions that we've been doing, like say this one back here that we did, you have questions like this where you're told you have 4 grams of methanol and they're reacted, how many liters of carbon dioxide will be produced? And I gave you the amount of this reactant, and this reactant we didn't even care about. We just said, whatever, there's lots of it. Or the fancy word that the textbook would say is that there is excess oxygen gas. So we're saying don't worry about it. Well, in the real world, you can't just not worry about the other reactants. You have to have a certain amount of both reactants. And so these problems that we did before were kind of naive, I guess, in assuming that there's lots of the other reactant. But like I said, in the real world, you have to worry about how much of the other reactant you have. So in an equation like this, hydrogen gas, oxygen gas gives you water, we need to be concerned, or we need to know how much of that reactant and that reactant we have. And usually it's just random amounts of these things, and because of that, one of them is going to run out before the other, and because it'll run out before the other, it will limit how much product, in this case water, we're going to make. So that's what a limiting reactant is. It's the reactant that runs out first and therefore limits the amount of product that we can make, the amount of product made. Which means the other one, which in this case is only 2 of them by default, would be the excess reactant, and that's the reactant that is, well, in excess. It's left over. Is left over, just like the word says, in excess. If it's just a simple little chemical that can be easily disposed of, or it's no big deal, then there's no big worries. But if that excess reactant is something that's poisonous, toxic, needs to be disposed of, then we need to worry about that. Okay, so here's a simple question, example. Here's the kind of questions you'll get. Now, I'll warn you right now, the questions are long and the answers are long when you get to questions like this. So here's the full story. There's the equation. I've already balanced it for you. If there's 6 moles of hydrogen gas and 4 moles of water, so we have a set amount of hydrogen gas, a set amount of oxygen. First, which of these reactants will run out first, aka be the limiting reactant? B, which of these reactants is in excess, or will be the excess reactant left over? And because of that, how many moles of water will we make? And how much of the excess reactant will be left over? That's a lot. Let's first break down how we can figure out the first thing, which of these reactants will run out first. There's 2 ways to do this. I'm going to show you both with this example problem. The one way we can do it is just straight common sense. Let's take a look at the equation. This equation says we need twice as much hydrogen as we do oxygen to make water. That could be molecules, dozens of molecules, or moles of molecules. So we need twice as much, because it's a 2-to-1 ratio, twice as much hydrogen as oxygen to react with water. Well, let's look at what we have here. We've got more hydrogen than oxygen, but is it twice as much? No. We have 6 moles of hydrogen, 4 moles of oxygen. We need, like the equation says, twice as much oxygen to react fully. So by common sense, we can determine that we don't have enough hydrogen. We need twice as much. we would need, in this case, if there was 4 moles of oxygen, 8 plus moles of hydrogen for there to be enough. But so in that case, hydrogen will run out first. It is the limiting reactant, and it will limit how much product we can make. If that's the limiting reactant, obviously that one must be the excess reactant, so it's oxygen gas. Okay. Now, that's one way of doing it, common sense. And with the common sense method, it's if you have the question in moles, you can do that. But most of the time, I won't give you the given amounts in moles. They'll be given in grams or liters or molecules or something like that. So let me show you the longer way to determine, but the way that works all the time, to determine that this is going to be the limiting reactant, and that's the excess reactant. And what you have to do, what you need to do is you have to use this as your given, and that is your given. It's like doing 2 stoichiometry questions in one. We have that given, see how many moles we're going to make of water, and then run this one through, 4 moles of oxygen, see how many moles of water we're going to get. Whichever one produces the least amount will be our limiting reactant. Okay, so again, common sense, we already know what the answer is. I'm just showing you the longer way, which will set us up for the next problem after this. Okay, so to figure out who's limiting, who's excess, with this longer method, we need to figure out how many moles of water we're going to make based on this, and then based on that. So let's first figure out how many moles of water we're going to make based on hydrogen gas. Remember, hydrogen gas was 6.0 moles. We want to figure out how many moles of water we're going to make. So to do that, what's the ratio between H2 and H2O? H2 and H2O, it's a 1-to-1 ratio. So 2 moles of H2, 2 moles of H2O. I know mathematically there's no point in doing this, but just do it anyways, because it allows you to slash out your moles of hydrogen. And this gives you, obviously, 6 times 2 divided by 2 is just like 6. 6.0 moles of hydrogen produced based on hydrogen. Now we compare that to how many moles of water we're going to produce based on the other reactant, which is oxygen. Okay, again, we already know the answer. I'm just showing you the method that's going to work for all questions. So we have 4.0 moles of oxygen, and we want to figure out how many moles of water we're going to make. So to do that, the ratio between oxygen and water, we look at the equation again. 1 oxygen, 2 waters. So 1 mole of oxygen for every 2 moles of water. They cancel out. You're left with 8 moles of water. 0.0. There's the 2 sig figs there. So based on this, we can see that if we based on hydrogen, we'd make that many moles of water. Based on oxygen, we would make that many moles of water. Which one's the true answer? Well, this one is, because whichever reactant makes the least amount of water obviously is going to limit how much water you're going to make. And I guess, like the old saying is, you're only as strong as your weakest link. Well, in this case, you're only going to make as much product as your limiting reactant. So this, by figuring this out, it actually tells you 2 things. One, which you already know, is that, I guess based on this, we know that therefore hydrogen is the limiting reactant. And it tells us that this is how much water we're actually, or theoretically going to make. 6.0 moles of water will be made. And this then, because it's going to make more water, this will be left over in excess. So your excess, excess like this, little symbolism, excess, your excess reactant is going to be oxygen. Okay, so that takes care of A, B, and also C. Now what about D? How much of the excess reactant, in this case oxygen, is left over? And to figure that out, figure how much of the excess reactant left over. This is a little tricky. Not so much for this one, but it will be later on. So what you got to do to figure out how much excess reactant left over is we need to find out how much of the excess reactant was used up, or how much reacted with hydrogen. So the way you do this is you want to go from the limiting reactant to the excess reactant. In this case it's moles. It could be liters, grams, molecules, whatever. The amount of the limiting reactant going to the amount of the excess reactant. That tells you how much of the excess reactant was used up. Now, is that going to tell us how much is left over? No. What we then need to do, so step 1 is to figure out how much of the excess reactant was used up. Step 2 is a simple one. That tells us how much we have used up. What's left over? Well, we subtract that from what we had at the start. So we had 4 moles at the start. We would subtract. Oops, I just gave away the next question. We're going to subtract what answer we get here from what we had at the start. So you take what you had at the start minus what was used up, and that will give us how much is left over. So let's figure that out. Let me just push this aside. Let's do this. How much excess left over? So we're going to have to do this first thing here, starting from the limiting reactant, which is hydrogen gas. It's 6.0 moles. See how much it reacted with, how many moles of it reacted with oxygen gas. So going from moles of H2 to moles of O2. The ratio was 2 to 1. 1 mole of oxygen, 2 moles of hydrogen gas, // you're left with 3 moles of oxygen that was used up. And to figure out how much is left over, then we do the second part of this little clunky situation. We had at the start we had how many? 4.0 moles of oxygen, and then we used up right here 3.0. Obviously 1.0 mole of oxygen, it will be left over to deal with. Okay, now that was actually a simple example because it just used moles. And because it used moles, we actually were able in the first step to figure this out just using common sense, even though I showed you the long way of doing it here. Now for the next example, you can't directly use common sense because now instead of moles I've given you grams. Now looking at this you would think, oh yeah, that's easy. Hydrogen's going to run out first because there's less hydrogen. Well, that's not the case. Because remember, it's not grams of molecules that are reacting to produce this, it's molecules that are reacting, and how many molecules are in this, how many molecules, like all that kind of stuff. Remember, that's what the mole is for. It's the link between grams and molecules. So don't just jump and think, oh, that's going to limit because it's the least number of grams and that's an excess. We have to actually change these grams into moles, and then we can do some calculations. So the method that I'm going to use is the longer method, but I think most students find it simpler to figure out what mass of water is going to be made. we're going to run this through 20 grams of hydrogen gas, figure out how many grams of water we're going to make. Then we'll figure out how many grams of water we're going to make based on oxygen. Compare the two, whichever is least is our actual answer. So let's figure out how many grams of water we're going to make based on hydrogen gas. So we have 20.0 grams of water. Convert to moles. And again, if you're ever stuck with all this stuff here, did I pick the right one with the mole map? Of course I didn't. This one here. If you're ever stuck, there's the mole map. We want to go from grams to grams. Molar mass, ratio, molar mass. Okay, so let's take a look. 20 grams of that we want to convert to moles. 1 mole of hydrogen is 2.0 grams of hydrogen, // We now are at the stage where we want to switch to the other chemical, water, and the ratio is 2 to 2. 2 moles of hydrogen gas are 2 moles of water, // Now we got moles, I want grams, and so just the molar mass. We know that 18 grams of water is what 1 mole is of water, // and you should get as an answer, which should be written to 2 sig figs, you get 180 grams is what you should get of water. Is that how much we're going to make? We don't know yet. Let's test the other guy out. Oxygen, 100 grams. So let's figure out how many grams of water we're going to make based on oxygen. 100.0 grams of oxygen. We want to go to 2 grams of water. So, again, 1 mole of oxygen over 32.0 grams, which is the molar mass of oxygen. The ratio between oxygen and water from the balanced equation is 2 to 1. 2 moles of water for every 1 mole of oxygen. Those are gone. Now it's the grams. 18.0 grams over 1 mole of water, // you get a final answer of 113 grams. Okay, so this is how much water we'd make based on hydrogen. This is how much water we'd make based on oxygen. So what does this all tell us? Therefore, this is what we know. Which was going to limit us? Hydrogen or oxygen? Oxygen will. It's going to make the least amount. So therefore, oxygen is the limiting reactant, and hydrogen in this case is the excess reactant. How much water are we going to make? It's as simple as seeing which one of these two is the least. Well, the limiting reactant is going to make the true amount of water, and so this is how much water we're going to make. So 113 grams of water are going to be made. Theoretically. Okay, so by doing that, it's a lot of work, but it kind of kills 3 birds with 2 stones, I guess. The trickier part is how much left over, how much excess, in this case hydrogen gas, how much excess left over. And remember, to do this, we have to figure out how much of the how much of the hydrogen gas was used up when it reacted with the oxygen. So you always want to go from the amount of the limiting reactant to the amount of the excess reactant. And that tells you how much was used up. This is like a general formula for these questions. And after you figure out how much you used up, you take what you had at the start of the excess reactant minus minus what was used up of the excess reactant, and that's what you have as how much is left over. So if you're a formula person, I guess this is kind of a formula you could use for these complicated parts when they ask you how much is left over. So We start with the limiting reactant, which in this case was oxygen. So we want to go from the grams of oxygen, because we have grams, and we want to go to the excess reactant, which is hydrogen gas, to grams of hydrogen gas. Okay, so how do we do this? Well, the grams of oxygen gas that we were given in the question was 100.0 grams. And we want to go slash 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 equals something hydrogen gas. Similar story. Molar mass, 1 mole of oxygen, 32.0 grams of oxygen. Grams are gone. Next step is the ratio between hydrogen and oxygen, which is 2 to 1. 2 moles hydrogen, 1 mole oxygen, slash slash. We got that. Now you want grams. The molar mass of hydrogen gas is 2.0 grams, 1 mole of H2, slash slash. When you do all that, you should get sig figs only 2, 13 grams of hydrogen. What is that? That's how much was used up. So we've done the first part. Figured out how much hydrogen gas was used up and reacted with oxygen. To figure out how much is left over, we take what we had at the start, and the start of the question, which was way back here, we had 20 grams at the start, so 20 grams minus what we used up. So remember, what we used up, which was this, which is going to go here, 13 grams. Now we're subtracting decimal places, no decimal places, so the answer is 7 grams. That is of the excess reactant left over of hydrogen. Okay. Now, if you got it, good. If you want another example, I'll do one for you. So if you think you figured this out, then go ahead and do whatever I ask you to do in class. But if you would like me to go through another example, here it is. This reaction, if I have 15 grams of this, 10 grams of that, what's the story? How much of this are we going to make? The question should tell you. If in this case there's 2 products. So here I'm saying let's pick H2S just because it's easier molar mass to calculate. That's the only reason for this one. And then figure out how much limiting reactant, how much excess reactant, the full meal deal for this question. Okay, so we want to figure out how much H2S made. Well, we want to figure that out. We want to first figure out how much we have based on aluminum sulfide. So based on aluminum sulfide. Okay, to do that, we get our 15.00 grams of Al2S3 times 1 mole Al2S3 over the molar mass, which, trust me, is 150.2 grams of that stuff, slash slash. Now we are at moles. We want to switch to H2S. The ratio from the equation is 3 to 1. 1 to 3, 3 to 1. So the 3 moles of H2S on top, 1 mole Al2S3 on the bottom, slash slash. You got that. We want grams. The molar mass of this is 34.1 grams over 1 mole of H2S, slash slash. You're left with a final answer of 10.2 grams of H2S. Is that the true answer? We don't know yet. Let's figure out how much 10 grams of water is going to make. So let's figure out the grams of H2S based on water. The more and more questions that you do of this, you'll find little shortcuts along the way. And some of you maybe already seeing some shortcuts. I am doing it a longer way, but most students find that they like this way better. Just less chance to make a mistake. So, grams convert to moles. I think you have this memorized. Water is 18.0 grams in molar mass. The ratio between water and H2S is 6 to 3. 3 H2S's. So we have 3 moles of H2S over 6 moles of water. And the mass of H2S, because we need the grams now, is 34 per 1. That goes on top. Over H2S / you get a final answer, trust me, of 9.47 grams of H2S. Okay, so based on all this information, we did all this work, we could answer 3 questions. Who's the limiting reactant? Well, water is, because, simple rule, whoever makes the least amount of product tells you 2 things. It tells you who the limiting reactant is, and it actually tells you the true amount, the theoretical amount of the product made. So based on all this, we know that the limiting reactant is water. And by default, the excess is Al2S3, and we know that 9.47 grams of H2S will be made. Okay, the clunky part is how much left over, the excess left over. And remember, to do that, it's just take the amount of your limiting reactant, go to your excess reactant. That tells you how much was used up. That's how much excess was used up. And then after that, take what you had at the start of the excess reactant, subtract from what of the excess reactant that was used up, and that then gives you what was left over. Left over in a mess that you may have to deal with. So to do that, the limiting reactant was water. So water was 10 grams. So 10 grams of water. Remember, the limiting reactant was water. From the original question, it said 10 grams. What we have. We want to then go to the excess reactant, which in this case is Al2S3. Grams of Al2S3, so we do the whole thing, 1 mole of water over 18.0 grams of water / the ratio between those two is 1 to 6. Trust me, we'll look at the top. 1 mole of Al2S3, 6 moles of water. Getting lazy, not even putting the moles in anymore. / molar mass is 150.2 grams. And Al2S3 / you get a final answer, trust me, of 13.9 grams. What does that tell us? That's how much was used up. Well, at the start, so now we're at this part here, at the start we had how much of the excess reactant, aluminum sulfide? We had 15.00 grams at the start, minus what was used up, which we just figured out here, 13.9 grams. You subtract least number of decimal places, which is 1. The answer is 1.1 grams of Al2S3 are in excess. Woo! Probably the hardest topic in all of chemistry, most complicated, clunkiest topic in all of Chem 11, done. Hopefully that worked for you. If you didn't get it, rewind, figure it out, pause it. Thanks, bye.